Okay, so here we have to explain the algebra of continuous functions with some examples. So the theorem is that suppose if f and g, are two real functions, which are continuous at a real number c, which are continuous at x equal to c, suppose. Then, so f and g means f of x and g of x are two real functions which are continuous at suppose x equal to c. Then the first rule is that f of x plus g of x, the function f of x plus g of x plus or minus also we can take. So f of x plus minus g of x is also continuous at x equal to c. Is also continuous at x equal to c. And then the second rule is that f of x into g of x is also continuous at x equal to c. Also continuous at x equal to c. The third rule is that f of x divided by g of x is also continuous at x equal to c. Okay, so so based on these, we can solve some examples. So example is that it is being asked to prove that the function f of x equal to tan x is a continuous function. Is a continuous function. So here, so the first we need to find the domain of the function f. So now therefore the domain of the function f is all real numbers minus 2n plus 1 pi by 2 where n belongs to z. So odd multiples of pi by 2 we should not take. Since why? Since tan x equal to sin x by cos x. So here, so it implies that cos x should not be equal to 0. It means x should not be equal to 2n plus 1 pi by 2, where n belongs to z. So now, so tan x is sin x by cos x. So the function f of x can be written as some p of x by q of x, where p of x is sin x and q of x is cos x. So now sin x is a continuous function. Since why? If I do limit x tends to c sin x, that will be, I can write it as limit h tends to 0 sine of c plus h. So that will be equal to, so I can put h equal to 0 here. So this will be equal to sine c. So I can tell that, so sine x is a continuous function. Sine x is a continuous function. And then similarly, if I do limit x tends to c cos x, then this is also limit h tends to 0 cos of c plus h. So that will be also equal to cos c, which so I can say so cos x is also continuous. Cos x is also a continuous function. And these values of x, which are odd multiples of pi by 2, we should not take. So since here both sin x and cos x are continuous functions, so here we have the rule that if f of x and g of x are continuous at x equal to c, then f of x by g of x is also continuous at x equal to c. So now, therefore, we can say that tan x is a continuous function. Tan x is a continuous function. Then so now if it is asked to prove that so hence we can say that so all rational functions so all rational functions are continuous functions. Since why? Since any rational function f of x can be written as some p of x by q of x, where q of x should not be equal to 0, where p of x and q of x are polynomial functions, where p of x and q of x are polynomial functions. And we know that any polynomial function is always a continuous function. Since if I tell p of x that is a polynomial function, then we can write it in the form it is a naught plus a1x plus a2x square plus dot 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 plus a and x power n for some natural number n, for some natural number n, and an is not equal to 0, and all these coefficients are real numbers, means ai belongs to R for all I goes from 1, 2, 3, 4 till n. Okay, so an should not be 0. So if px is this, then px is called a polynomial function of degree n. Fx is a polynomial function of degree n. So now limit x tends to c, p of x. If we put x equal to c here, we can put, so then it will come p of c. So we can say, so the function, so the polynomial function, p of x is continuous at x equal to c, where c is any real number, where c belongs to R, means c is any real number. So hence we can say that any polynomial function is a continuous function. Any polynomial function is a continuous function. And so we can tell that all rational functions are continuous functions also. So hope you have understood the concept. So thank you.